And make sure that your microphones are muted if you have a microphone. Okay, so we're doing question 37. It says to find the product, which means multiply. 6i times 3 plus 9i. 6i times 3 plus 9i. To find the product, you distribute. Oh, thank you, Gage. Very sweet of you. So 6i times 3 is 18i. Plus 6i times 9i is 54i squared. We're almost done. So that was actually how easy it was.
Oh, really?
And then, yeah, well, yeah, we're almost done, except there's one more step. Do you remember last time we started out by proving that I squared equals -1? Remember that? So whenever you get an I squared in these problems, thank you very much, Cameron. Good job. No problem. I appreciate your dedication. Good job. I admire you. So then we have to multiply, put in a -1 for the I squared, and then we get 18i minus 54, and then that's the answer. That's the final answer. 18i minus 54. There we go. Did you know that in 1854 they hadn't even had the Civil War yet, even?
Oh, really?
So 1854, wow. Yep. Okay, so then let's do one more product. So just to make sure you know how to multiply. Ready? I'll let you pick 40 or 41. Do you want to do 40 or 41? Yeah, yes. Yes. Yes, that's fine.
Thank you.
40 or 41? 40, okay. I'll wait just a second more. Let me know when I'm all right.
1 more minute.
Ah, thank you, Walker. Great job.
All right, we'll get you go.
Okay, perfect. So 40, question 40, it says oops, I already turned the page accidentally. Question 40 says to do 2 minus 5i times -3 plus 7i. So this is about as hard as it can get. We're doing a huge multiplication problem. We have to distribute everything. So 2 times -3 equals -6. 2 times 7i equals 14i. -5i times -3 is positive 5i. No, not 5, sorry. It's positive 15i. My fault. The -5i times positive 7i is -35i squared. We got to combine like terms. So positive 14i plus 15i is 29i. 29i. So it equals -6 plus 29i. Now I'm stopping for a special reason. Who remembers what I squared equals? Who can remember what I squared equals? -1, right? So, whoops, I didn't mean to write equals right there. Sorry, my fault. By the way, can everybody see a screen? Because I just realized I forgot to email the link to people that weren't here yet. Can everybody see a screen? Okay. Okay, good job. So -35 times -1 is positive, but okay, perfect. It's positive 35. So we're going to change that to positive 35 because of the -i. -1, I mean. Now we have to combine two more terms together. Which two terms do we have to combine together? Yep, -6 plus 35, which equals, wow, this is so cool, 29 again. Who would have thought 29 is so special? So 29 plus 29i, that's the solution.
I'll change it for a minute.
Perfect. You guys are amazing. By the way, we're almost done. Like spring break, fall break is like so close.
Isn't it? It's almost.
Yeah, really? Oh, that's cool. I'm excited. So then my fall break is like after 3 o'clock, like after like lasts until 3 o'clock. Then finally I can have it. Okay, so then 40. Okay, so everything else is multiplying all the way until problem 43. So we're gonna skip those. Unless do you want me to do 43 just to be safe? Should I do 43? Yeah, let's do 43 just to be safe. Ready? 43 just to be safe, because we want to be safe. So -25. Whoops. Why do I always skip the first number? I think my brain has a problem with it. Square root of -25 times square root of -4. And remember, how do you take a square root of a negative? You pull an I outside. So you get 5 and then I, and then 2 and then I. And then what's 5i times 2i? 10i squared, right? And then 10i squared is equal to 10 times negative 1. What's 10 times negative 1? Negative 10. So boom. So anytime you have an I squared, it just changes the sign. So if you have 10i squared, that's equal to negative 10. Now the last kind of question we have to do, well, actually we have two more kinds. We have to learn how to divide, and then we have to learn how to do exponents last. So we really have two more things to learn, but we're almost done. How do you divide by imaginary numbers? So 44, you ready for it? I want you to remember that you'll be so thrilled of yourselves. 6 over 5 plus I. You'll be so thrilled of yourselves when you learn how to do this. I don't want to say proud of yourselves because like pride is like bad, but you'll be thrilled of yourselves though. That doesn't even sound right, but 6 divided by 5 plus I. Oh, wait, I already cheated and told you the how to do it. So first of all, imagine you didn't see what I circled. How can you cut a pizza into an imaginary number of slices? Like if you have a 6-inch pizza, how do you cut it into like 5 plus I slices? That's impossible, right?
Yeah.
So the only way to do it is to rationalize the denominator, and we already learned how to rationalize the denominators before. How do you rationalize the denominator? By multiplying the denominator by what? The conjugate. So it's the same way. So when you have a denominator that's 5 plus I, that's not a real number. So you have to multiply by the conjugate of 5 plus I, and what's the conjugate of 5 plus I? 5 minus I. You switch the sign in the middle. So that's why I multiplied by the conjugate. So we're going to distribute this. So what's 6 times 5? What is 6 times 5? 30. What is 6 times negative I? Negative 6i. And then what's 5 times 5? 25. What's 5 times negative I? Negative 5i. What is I times 5? Positive 5i. And what is I times I? What is I times negative I? It's negative 1i squared, right? Boom. So how's that?
Keep it there for this one month.
Perfect. By the way, I actually realized that I forgot a shortcut. Do you remember we learned a shortcut for multiplying conjugates together? What's the shortcut for multiplying conjugates? One conjugate times the other conjugate. Well, notice in the middle of this, we have negative 5i and positive 5i, right? And we can cancel those out. And remember that that's actually always happens when you have a conjugate times a conjugate. The middle two terms always cancel out. So you really only have to multiply the first and the last. So that's the shortcut that I forgot. But it doesn't hurt if you forget the shortcut. You can always do things the long way and the hard way. Although it's better to do it the short way and the best way because it's more efficient. But it didn't hurt us though. So I'm almost done. Should I stop here or is there anything else I can do?
Is there anything else?
Yes, because look at the I squared. Remember what is an I squared? Yes. So what do you think it is if it's negative 1? What is a negative 1? Positive 1, right? So this actually becomes positive 1. So you get 25 plus 1, and then you get 30 minus 6i on the top. What's 25 plus 1? 26. So you get 30 minus 6i over 26, which is almost the answer, but not quite. What do I have to do? There's actually just one more irritating step. It's like a mosquito that's trying to bother you. No, but the I is okay, but we need to get rid of notice that there's all three numbers are even numbers. So we can divide everything by 2 to just reduce it. So I hate those little pesky things that happen at the end of a big, beautiful problem, but that's okay. So 30 minus 6i divided by 2 is 15 minus 3i, and 26 divided by 2 is 13. By the way, I don't know how picky the computer is going to be. Hopefully the computer will be nice and accept it in traditional form. So leaving it like that is called well, it probably doesn't have a real name, but I think of it as just traditional form, like the answer is the answer. But sometimes the computer wants you to put it into the form of a plus bi, which is terrible. So this would be 15. I'll explain how to do it just in case this first answer doesn't work. So 15 over 13, and then negative 3 over 13, put the I beside the last one. So basically you're separating the fraction apart into the 15 over the 13, and then the negative 3 over the 13, and then the I is on the right side of the 3 and the 13. So hopefully you don't have to separate it out like that, but just in case you do. This form is called a plus bi form. And this form down here is just like regular, like traditional form, yeah. You have to, okay, so he says you have to put it like that, so.
The A plus B.
Yeah, so I guess you have to do it like the a plus bi form, just so the computer can like grade it more easily, I guess. Okay, so now the last thing actually, let me do one more example of these, because this is kind of hard. Let's do one more, I'll let you pick. Do you want to do 45 or do you want to do 48?
48.
Okay, so, no, I'm sorry, my fault, no, I didn't mean that, sorry. Do you want to do 45 or 46? Do you want to do 45 or 4? Those are the hardest ones. Well, let's do 45, okay, so let's do 45. So 45, because it's a good day to be alive. Perfect. So 9 minus 3i over 8 plus, wait, actually, I think 46 is harder. Do you want me to do 46? Okay, 45 is okay, okay. It's the same way, the numbers are just gonna be slightly bigger in 46, that's all. So 45 is 9 minus 3i over 8 plus I. So every number is kind of big except for the I is kind of small on the bottom, so. But the principle is always the same. How do you divide by something that's not like a real whole number? You rationalize it. So how do I rationalize the bottom of this fraction? Multiply by the conjugate of it. So multiply by 8 minus I. Boom. Now I'm going to the top of it. I have to do the long way on the top because the top of it is not a conjugate times a conjugate. So I'm going to have to distribute the whole entire top. So it's 9 times 8, 72. 9 times negative I is negative 9i. Wait, why do I write my i's like Q's now? I think it's just not working. There we go. And then negative 3i times 8 is negative 24i. And then negative 3i times negative I is positive 3i squared. So now on the bottom, though, I can do the shortcut. And who remembers the shortcut? What's the shortcut when you have one conjugate times the other matching conjugate? Just have to do the first and the last, right? So 8 times 8 is 64. I times negative I is negative I squared. So we're almost done with this, and we're almost ready even for fall break even. So negative 9i minus 24i, what's that? If I combine the negative 9i together with the negative 24i, what is that? Negative 33. Ah, perfect. Negative 33i. And then 72 stays the same, but then what is 3i squared? What does 3i squared break down into? Yes, exactly. So 3i squared is kind of like a student with too much math. They kind of break down into like a negative difficult moment from a positive 3 to a negative 3. Just kidding. Then in the bottom you have 64, but then the negative I squared becomes what? If I squared is negative 1 and you have another negative in front of the negative 1, what's a negative negative 1? Positive 1. Exactly, plus 1. Right. It's like being a plus 1. So 72 minus 3 is 69 minus 30. It's too bad it's not 67. 72 minus 3 is 69 minus 33i divided by 65. Okay, does anything reduce from this or not? No, because there's nothing that goes into 33 and 65 and 69 all together at the same time. So we don't have to reduce this, but we do apparently have to put it in the form of a plus bi. So it's going to just put this real number over 65 and then put the other number over 65 with an I beside it. That's called a plus bi form. And there's not any real benefit of a plus bi form. It just makes the computer be able to grade it easier. Sorry about, by the way, does anybody else, let me check the participants real quick. Is anybody else still trying to get into the room?
I left.
Okay, you left. Okay, good. Oh wow, wait, I like your logo. One of you has like a really cute logo. Wow, smart. I need to get a logo like that for myself as well. Okay, so 45. Okay, so there's only one thing left to learn. You ready to learn it? How to do exponents of I. So first of all, I'm going to teach you a trick. Anything to the 0th is always, who remembers what something to the anything to the 0th is what? 1, right? And by the way, 0 does not count as anything because 0 to the 0 does not equal 1. 0 to the 0th is undefined. But I is not 0, so that works. And anything to the first power is, what is anything to the first power? Itself. So I to the first is equal to I, and we already know that I to the second is equal to what? I to the second is equal to what? -1. And so therefore, what is I to the third? I to the third is really the same thing as just saying I squared times one more I, right? So if you look back at the I squared, which is -1, and you multiply by an I, which is I, what's -1 times I? Negative I. Okay, perfect. Now let's do I to the fourth power. What is I to the fourth power? Well, look on the left of that. I to the fourth is really the same as I squared times I squared, right? But we know I squared is -1, right? So what is -1 times -1? +1. And then it starts repeating because remember, I to the fourth is 1, just like I to the 0th is 1. And then I to the fifth is going to equal I, just like I is equal to I. And I to the sixth is going to equal -1, just like I to the second. So every fourth power of I is the same as the fourth power before it. So I to the sixth is the same as I to the tooth. I to the tooth, that sounds like a dentist. I to the seventh is the same as I to the third. I to the eighth is the same as I to the fourth. It just cycles around. So that's the idea that we're going to be using to do all these last like 5 problems. In fact, there's only 3 actually. So let's do them all. So 48. 48 rhymes with great. Sweet. Okay. Do you think we're going to win the national? Well, we can pray for us to win the national championship by 48 points. Wouldn't that be cool? So I to the 51, I to the 51 power equals, wow, that's a huge number. So first of all, how many multiples of 4 go into 51? How many times does 4 go into 51? Well, it doesn't go into 51, but it goes into 48 though, right? So every time it goes into 4 times, it just cancels out. So what's the remainder? What's left over after you divide 4 into 48? How much more is there in 51? 3. So that means that I to the 51st power is going to be an exact match with I. It's going to equal I to the third power. So we just have to go back and look at this. And what's I to the third power? -I. So boom, you've got the answer. So let's do 49. So 49 says, what is I to the 38th power? Wow, that's insane. So first of all, how many times does 4 go into 38? Well, it goes into 36 9 times, right? So since 4 goes into 36, that means that 36 doesn't matter. What's left over after taking 36 subtracted from 38? There's 2 left over, right? So I to the 38 is equal to I to the second, actually, because every time 4 goes into it, it just cancels out. So there's 2 extra powers left over after dividing by 4. And what is I squared? -1. Now 50 is next. Uh-oh, 50 is more complicated. Wait, this is so hard. It's -I to the 12th. Well, we can't use the same exact trick on -I to the 12th. Guess why? Because there's more in it besides just I. Except we can still use common sense though. So when you do a negative to number, like negative something to an even power, what do you get? Positive. So this is actually going to equal positive I to the 12th, right? So, and of course, you don't really have to write the positive sign. You can just get rid of it. So negative to the 12th equals a positive, right? So then you're just back to I to the 12th. And does 4 go into 12? Yeah, so what you're left with is 0. So you're left with I to the 0th. What is I to the 0? 1. So boom, we're done. So now you know how to add, subtract, multiply, divide, and do powers of I. So are you ready for fall break now? Wait, we have so much extra time in class, but I guess I can give you a little bit extra vacation. So before you go though, did everybody get signed in onto this amazing and beautiful sign-in sheet? No. Okay, so I'm going to put the sign-in sheet right over here at this empty area where nobody is. And then you and maybe some other people around here can write your names on it. But before you go, make sure you sign your names on this page. Because remember that attendance is worth a grade in this class. And every time you miss class, it slightly takes off more and more and more points. So make sure you sign your names on that and don't lose any points. And have a wonderful fall break, everybody. Be safe and be happy and be responsible. Thank you very much. See you later.
Because my own money.